fuel cells have potential in solving the global warming problem. Fuel cells, people have heard of them now quite a bit. If I ask my students in the first year, almost 100% of students have now heard of fuel cells. They know what they are. They're not quite sure how they work, and they're not quite sure how they're going to be applied in practice. Say to vehicles, you can put fuel cells in vehicles, you can put them into buildings, you could have them in aircraft. So here's a ubiquitous sort of technology which can produce zero emissions and much more efficiency, utilise fuels much more effectively. Well, the idea is that we don't need power stations if everybody has fuel cells. It's a good example of a distributed technology, a bit like wind power, you might say, or solar power, but those are intermittent. Fuel cells can run, say, on gas. Instead of your central heating system, you have a fuel cell system, and that generates your own power, generates your own heat, saves half your bill, essentially, because you're much more efficient, and then you've got much fewer emissions going into the atmosphere, and so global warming is then reduced. Yes. And so if every 22 million homes in Britain, if everyone had a fuel cell, we don't need any power stations, no nuclear, no coal.
We all become part of the grid.
Yeah, we're distributed. We all contribute. And it's so secure, it is so effective. If some go wrong, you use the grid and bring other people's electricity in. It really is a super system. There's one in your car. Your car has a fuel cell. It's the oxygen sensor in the exhaust which drives the emissions catalyst. So it already exists. That's, of course, quite an expensive one because it's produced a signal which controls your vehicle. But if you string maybe thousands of those together to produce power, then you could have one in your home. You could actually have one in your car to supplement the engine, because right now the battery is the weak point in the car. Replace the battery with the fuel cell and you're in business. It's going quite fast. I think people feel that commercialization is imminent. The one successful area right now is aerospace. Already every space shuttle, every spacecraft has a fuel cell on board. It's the best way to produce electricity in space and water in space. For cars and houses, combustion technologies have dominated, and they have to be. You have to compete with them. Yes. That's the problem, competing with our combustion engines, gas turbines, etc. I'm not sure what the audience is, but I hope they've heard of fuel cells. I want to first of all show examples of how right now people use them in space, in aircraft. That is already successful. Then how would you put one in your car, for example? How would you put one in your house? How would you have one in your laptop? These are the questions that I want to ask. Absolutely. I mean, you think of a battery right now. You have batteries everywhere in your toothbrush, battery in your transistor radio, in your camera. Every battery will be replaced by a fuel cell in my lifetime. Well, the fuel cell is just an enhanced battery when you think of it. The problem with batteries is they're too heavy and they run out of electricity. So battery vehicles have worked. You know, a century ago, battery vehicles were competing with combustion engines, but they're too heavy because you've got energy stored in metals, in lead, for example, which is a crazy idea to store energy in lead. But that means it runs out and it's too heavy. If you have a fuel cell, it's lighter weight, you keep feeding fuel in, say hydrogen, you keep feeding it and it keeps running. So here it's an enhanced form of battery. Well, hydrogen is a key fuel because hydrogen is everywhere, obviously not as raw hydrogen, but it's everywhere in methane, in biomass. Everywhere on the planet we find hydrogen. All we have to do is in water, we can convert water into hydrogen from renewable resources. And then this hydrogen can then react at room temperature. So that means you can run the fuel cell at room temperature. Other fuels, say like methane or butane, petrol, they need higher temperatures if you're going to use fuel cells with those fuels. So that's the secret for hydrogen. It reacts at room temperature. We can use it in our laptops, for example.
That's an amazing thought, isn't it?
It is, yeah.
With smoke coming out one side of it.
No, there'll be a little wisp of steam. No, there's no smoke. No, it's zero emissions as long as it's only steam coming out, yeah, because remember, everywhere you have a combustion, like your car engine, is deadly. The emissions coming out are horrible. Yes. The same with aircraft, the same with your gas cooker. There are emissions coming off there which are significant. We don't recognise that. Carbon monoxide, NOx, particulates, all these things. Now, fuel cells just don't have those. So that's the real secret. We get rid of emissions. We're on a new level. There's an element of both. I mean, from the science point of view, we're very cooperative, because we learned from the Japanese and the Americans and Germans are very strong on fuel cells. Scandinavians, I mean, in Scandinavia, have much more fuel cell research than in Britain. Small countries can be very keen on this. Even Turkey has more than Britain right now, would you believe? Which is a bit astonishing. But if you go to America, it's absolutely huge. It's billions of dollars. In Japan, again, it's $500 million of funding for these sort of technologies. And eventually, the small companies which are now working on it will grow and produce the hardware and the fuel cells we need. The UK policy is quite interesting because it's very sort of varied, very random. If you go to a place like Japan, if you say visit the fuel cell meeting there, 30,000 people turn up in Japan this February. If we had a similar meeting in Britain, we'd have 300. That is the difference. It's about communication, about getting enthusiasm, about getting progress. And look at Japan, look at Korea. Now that is where our politicians should be looking, because these people, and even China now, these people are moving ahead. They see this as a real future. We're very much free market. It has to compete. Obviously, as incentives come through, because global warming is producing fiscal incentives, then fuel cells will look more competitive. Yes. It has to compete with existing combustion technologies. That's quite difficult, because here are well-established, mature, almost fault-free technologies. So it has to compete with those. And it's got to do it on its own merit. You can't subsidise this fully, but one can support ideas. The real question is to support individuals. You've got the idea of small companies and then build these things, and it can become a more global enterprise. We talk to oil companies, they're very interested in fuel cells, but people see here's a prospect, and you look at the trend, they're moving from oil to natural gas, methane, towards hydrogen. They see it, but it's obviously a long time scale, 50 years, 100 years, whatever we want to look at it. It's in there, the plan is there, it will take time. Well, my prediction in 2010 is that you're very likely to have a fuel cell laptop. Now you might say, well, that's not solving the global warming problem. But look at laptops. Everybody's now got a transformer wasting 10 watts overnight the whole time. We've got several power stations operating in Britain, which is just powering laptops essentially, because people won't switch these things off. It's a major influence, and this will come from Japan, possibly Korea, and the United States. Unfortunately, we're not geared into that market in Britain. That's a sad tale. In that area, I'd say we're lagging behind 100%. And that's just a fact of our electronics and computer industries.
But what can be done to influence a change in that?
I don't know. Go to Japan and buy one. Go to the conference. Go next year to Tokyo in February and see 30,000 people looking at these devices with great enthusiasm. That's what we need over here. Come to Grove in September. We're running the Grove conference. There'll be 700 people. There'll be 50 Japanese people.
Where will that be?
In London, Westminster. Come to that, because there we'll have an international meeting bringing these ideas together. The exhibition will be modest. There'll only be maybe 1,000 people turn up to the exhibition, compared with 30,000 in Tokyo. But the fact is, we're gradually moving forward. We've just got to keep that momentum going on. In your home, you probably have a natural gas central heating system. I've got one. It provides, say, 20 kilowatts just of heat. Chemical engineers, heat is waste. We're just wasting fuel. In there, we should have a fuel cell which provides power and heat. Obviously, we've got to build better homes which don't need as much heat. Our best English home is worse than the worst Swedish home. Why is that? But each of them will have a fuel cell. We'll generate our own power. At some point, the companies will buy our power on the grid, so we'll be able to sell it to gain money when we're not using it ourselves. We'll export it to our neighbours. We'll power all our house. We'll immediately halve Britain's fuel bill. You talk to the companies in central heating, they're doing it. They're doing solar power as well, and they're also doing ground effect power, heat pumps. But yeah, they've got their eye on this. Sure, it's one big alternative for them. The government have put some support into companies who claim to want to do this. That's good, and hopefully they'll continue to do that. I mean, I think the big thing from the government has been clean transport, because that's more urgent. If you had fuel cell vehicles, and look at Honda, they've integrated the vehicle and the home. So you have a hydrogen home with fuel cells, you have a hydrogen vehicle.
Where is this?
In Honda, in Japan. So they're now they're already leasing some of these in the States, and they're hopefully bringing some into Britain next year. Yeah. So here's one possibility. We should be thinking very much of this rather forward thinking. We have a hydrogen economy, as it were. Now, people are a bit scared of this, of course it's different, but in 50 years we will have that, I think. Yeah. And we have to lay the seeds of that, put the seeds of that in place. We are made of carbon. Biomass is carbon, and of course fuel cells aren't fuel. A fuel cell is just a more efficient way of using fuel with lower emissions. That's great, we've got to do that, but where's the fuel coming from? And I see biomass as being the key issue there, and we work on biomass as well. I'm going to show a slide showing biomass to hydrogen. Yeah, so carbon is not going to go away. No, but the understanding of how you use the carbon, use the hydrogen, and the science of tapping into that, that's what we need. Yeah. People can't do it. It's not easy. Cellulose is the main carbon waste in Britain. It's just rotting, it's dumped, and people burn it. Why is that? Because they haven't got the science and technology to utilise that and tap into it for our benefit. That's what's needed. It's happening already. Let me give you an example of our university. We have a fleet of 100 vehicles on our campus. Right? This year we're getting 5 hydrogen hybrid vehicles. So we're going 5% towards zero emissions. That is a move. If we can go 10% next year, maybe 20% in a few years' time, 50%. We move through that towards 100% zero emissions. We've just got to start off and gradually do it. Of course, we'll see some snags. First of all, it's a bit costly. Where do we get the hydrogen from? All these little snags are in there. Do the materials corrode? These are typical problems. We will overcome these. It's just a process of time and science. Well, realistic. Optimism is a bad thing. People said we'll have fuel cells in, they said we'll have them in 1998. You know, there was California legislation saying we'll have fuel cell vehicles in 1998. This didn't happen in Los Angeles. Why? You asked that question. We don't want that optimism. We want realism, that if we go 5% this year, 10% next year, we can build and get towards that hydrogen economy in a reasonable space.